Okay, your machine shop instructor Ed here on part 2 on the Titan Mastercam on the Titan 1M. This is my drawing in CAD, and I'm actually going to open up the one I finished in CAM right here. And it's actually now prompting me to save this particular file. Usually if you're bailing out or you've made a change, it's asking you to reminding you, do you want to save the file? And I didn't make any changes, so I'm going to say don't save. Alright, so here's my Fusion file, toolpaths, and I'm just going to close all those up and shut off the toolpath. Okay. I'm going to hit the fit command, and there's my model, the one I drew, and I saved it, and I just called it CAD CAM or CAM, I forget what I called it. But so at this point I had to now go to what machine I was going to use. So I went into mill, managing my list. If you're using the HLE, you're just going to have like 2 machines over here. But when you get into the real machine kind of part, and we go to run it in like inside the licensed edition in the school, we'll have to assign the machine. So in this case, I probably should erase a lot of these. STC, VF2, STC, Haas, TM1P. And over here would be I add them to this group. So if I want to add another machine like this Techno Da Vinci thing, I would hit add, and so when I go up here, it's in my little list. So this is like, I don't need to go into the big list, I already have this list. But I already have it right here. So when you select one, it's going to populate this little area right here. Okay, and that's about all you need to do in this section. But once you do that, now you get toolpaths. 2D, 3D, multi-axis, and some stock selections in Tool Manager. So, and this window gets a little bit bigger. We got contour, drill, anything with the red Mastercam calls dynamic milling, which is technically called tricordial milling. It's the high-speed machining techniques, and the Fusion 360 equivalent is adaptive. So it's got dynamic milling, dynamic face milling, dynamic contour milling, and something called peel mill. This is 2D dynamic. Over here, we have just one called OptiRough, which is 3D, which is equivalent to 3D adaptive. And then you have all these other 3D functions, like which way you want to machine it. A lot of it's pattern-based. And then we get a little deeper. We can get into multi-axis. These are actual blade expert. This is for cylinder head porting, 5-axis deburring. So Mastercam is a very powerful product. So when you get into the heavy-duty areas. Okay, so in this case, here are my operations, and notice they're all folders. All folders, and they got a red arrow here. So if you want to insert something at a certain point, you can move this around. But the first thing I would do is you go into here, you've selected the machine, and you want to go into files, make sure this is populated. Go to tool settings, give it a program number. I prefer to have these 2 checkboxes, assign tool numbers sequentially and warn of duplicate tool numbers. And then I click this override defaults with modal values, because as you start to write the programs and you tend to do things a certain way all the time, it'll actually update as it goes. That's kind of a nice, powerful thing, like these 3 right here. It's got I think when you power this thing up, wrong box, it'll be aluminum 2024. Not that important right now, But if you want it to be exact, you can go to Mill Library and pull that in there. So I have the aluminum. Let me go back here. Select 6061. Okay. All right, and then we have stock setup. Very different in Mastercam than Fusion. I'll get along. Let me actually just give a quickie. I'm not going to do the setup. So right here, it's got 2-inch, 4.1, and 1, and you had to tweak these settings to get the corner to come out right. And also, you can actually move this around to different corners. And it says rectangular shape, cylindrical be for lathe. This where the stock is going to be aligned to the top plane. Or you can bring in a file, which would be something that's been pre-machined or pre-modeled. And we'll get into some of these selections down here. And then we're going to start selecting operations. So go up to here and hit face mill, and we'll go on and on. So what I'll do is I'm going to start fresh with a new one. But I'm just going to go over these ones that I already did. All right, so I got, if the folder is checked, that means you're working on that operation. And the toolpath, if it's gray like this, it's not shown. And if you hit this, it's now shown. So that is rapid, feed, rapid. Okay, some similarities there. If you go into parameters, you notice it says facing. And you pick a tool up in here. So when you go to select the library tool, it's a huge library, but I have it filtered right now to be just face mill. So if I pick all, and I go back to here, I got like all the tools. Like new, I just want to look at the face mill. So hit none, and then pick face mill only, go back. And notice they have big numbers here. So that's why the ordering by selection will you'll keep you for having to update all the numbers. So you'd have 3-inch face mill, which we selected, which is up here, and it would populate this. And at some point, you're going to have to start putting your feeds and speeds in here. Personally, I like to copy this down to the comment column so that it appears in the code. Make sure it says clockwise direction. Spindle speed, so if you can say I want 2,000 surface feet per minute, it'll self-calculate. Fusion does the same thing. And feed per tooth is your chip load based on how many flutes that has. And typically, whatever it calculates up here, I like to do the plunge rate at half rate. The holder is not that important. Cut parameters. So you have zigzag, one way, one pass dynamic. So this tool is big enough to do one pass. So I pick one pass, stock to leave, nothing on the floors, and you might have to play with these numbers for the extension and all that. Depth cuts. This will be like a second operation. You need to do multiple cuts. We're not doing that. Linking parameters is heights. I always have clearance height. I always set it at 1 inch absolute. And absolute means from 1, 0. Incremental means from wherever object you've selected. So this one I got absolute 0. Top of stock. It's identified as being a little up. So it's going to be 20 thousandths is above 0. So we can get into some of these selections later. Home and reference, skip that. Arc filter tolerance, skip that. Planes, we're on top plane, and it actually has WCS and these other two here. And make sure this is on automatic for now. Coolant, it should be on. Hit the blue plus button. If you hit green, it'll close this whole window. You don't want to do that. Just lock that in. Canned text not needed, miscellaneous values. So none of these other ones you need. Now you can hit green check. And then you have, so get parameters. We know it's a face mill, and this one says geometry, job, setup, stock boundary. And this would be the toolpath. So if I press this little backplot button, it'll run just that tool right here. This is like a quick simulation, and this is your speed bar right here. And this will be what you want to show. Do you want to show the holder? Do you want to show that part? You know, better with the end mills. Okay, let's go to the next one. And I was learning how to do the settings, super high-speed dynamic OptiRough, which was this one. Okay, I want to shut that blue line off. So I shut that one off. I'm going to checkbox this one, which means I'm working on this one only. And this is the toolpath for that one. Okay. Parameters. It says dynamic OptiRough roughing, model geometry. This is going to be how much you leave on the wall and the floor. So I would set that. Machining, and you're going to select the object, select entities. So right here it says I would use triple click to select solid, which will select everything. Then you have to hit end selection, brings you back to here, and say, yep, I'm okay with all that. Toolpath control. This is where it gets a little, you got a little more selections in here. I had to make something called a boundary chain. I'll go over that later. And you got this stay inside, stay outside, compensate to inside. All right, I'm going to blue check that one. The tool we selected was a 3/8 flat end mill. And I pumped in, and I'm going to shut up this RCTF right here. That's called radial chip thinning formula. I'll get into that later. So I know I can run in the VF2 8100. So I've just pumped in 750. It gave me 7640. That's cool. Make sure this rapid retract is on, so this won't do that. I put in feed per tooth, which actually self-calculated that. And in this one, if I ended up with something like 5 down here, I don't want that to be slow, so I can put in 61 divided by 2 and then hit the tab button, and it'll self-calculate. And I got the end mill comment down here. Or you can just say roughing, so it identifies. Holder, not important. Stock, not important. Cut parameters. Okay, there's more settings in this one. Climb mill. You want to have step up on, and step down, you want to have more than the thickness of the part. So if I say 2, this is actually based on the size of the tool. So if the tool is 0.375 diameter, 200% would be 0.75, which is about the length of the part. So if you play with this number, it'll cut down on how many levels it cuts, because this should be able to cut at totally deep level. Step over is how much it goes in these directions. So in this case, 25% of the end mill diameter would be like 93 thousandths. Step up is kind of like it's bigger in the 3D world, like how close do you want to stay to the boundary of the 3D form. In this case, this is 2D, not that important. I like using the micro lift of 10 thousandths, and I would set the back feed rate at 400 inches per minute. Okay, transitions. I would just leave this the way it is. Helix method, steep, shallow, we'll get into that. I actually had to force, so you could do detect limits, and it was trying to cut the top, and it's already been face mill, so I actually went a little bit below top so it wouldn't cut the top. Linking parameters is the height selection, but it's a little bit different on this one, so I put in absolute 1, I left all these the same, and I put full vertical retract. Arc filter I left alone, planes are still on top, coolant should be on. Okay, and other than that, I'm done. Anytime you make a change, it'll be a red box here, and they call this a dirty operation. You got to regenerate. It says regenerate all selected operations, which that's the only one selected, so I do that. This is called threading, and it's calculating right now. And right now it's not showing the toolpath, so I have to flick that little button. So in this case, I'm looking at yellow lines, rapid moves. spiraling in, and pretty similar toolpath to the adaptive. It cutting out this way, and it did a couple outsides. When I did not have the boundary, outside boundary, which was this, I'm sorry, toolpath control, I'm going to deselect the boundary, which will make me want to regenerate. It would not cut the outside. It's the difference between Mastercam and Fusion. Fusion is actually very intelligent on the adaptive stuff. So it identified the solid, and the stock size is identified. So we actually have to give it a kind of a boundary of what we think the stock will be, or what kind of boundary that can we use to get the end mill to go around the outside. So in my levels, I made a box called boundary, that rectangle. It didn't really matter how deep it was. So I said from my top view, I want the end mill to go inside this box, but outside this, I want it to rough outside here. Okay, so I go back to toolpath parameters, and now I go here. This says select the boundary, and this is called chaining. This is wireframe chaining or solids. This is a wireframe, and I want to select just that. So I'm going to select that. Direction does not matter. Green for OK. Brings me back to here. I want to compensate to the inside. So you can play around with these settings and see what you end up with, but I'm going to compensate to the inside. Hit the green check mark. Press the green arrow. Regenerate. And now I got it to finish the outside. Looks like there's like 2 loops there. All right. I want to be too lengthy on this. Shut that off. And then I went to contouring. I'm sorry. Let me go back here and unlock that. Shut that toolpath off. Why does that keep unlocking? Toolpath. Oh, I don't want that. Unlock. No toolpath. Contour. Contour, unlock. So contour cut is, let me just show that one. Just kissing the outside. Geometry selection. Pocketing. So I'm going to shut that one off. Go to pocket. This is just cutting the floor. So similar selections of Fusion. So this is actually finishing the floor and the wall, so with no contour. We did have to finish this floor here. So instead of doing a pocket routine, I did a contour routine with something called multi-pass. And oops, looks like I made a mistake there. It's a little bit low. Let me check my linking parameters. Incremental depth. Depends on my boundary selection. Let's see, parameters. Toolpath type. Change geometry. Here it is. Change geometry. I picked the right boundaries. So this is called a partial loop. Start here and there. I'll have to check the code on that. And I'm using wear compensation. Stock to leave on floor is none. Lead in breakthrough. Ah, that's where it is. I gotta shut that off. Shut that off. We had to use breakthrough for the outside. There we go. It's all fixed now. I knew it was something. All right, and then the rest is chamfering, chamfer, drill, pectoral tap. Okay. Isometric view, fit. And to do a simulation, you do this little box right here. It's going to pull up a separate window. over this side, it actually gives you total time. I'm not sure if this is updated correctly, but anyway, I can run this from here. But I have to have over here, I have to have all selected. Right now it's only going to run that. So if I click up here, that's everything selected. So I believe I want to redo correctly. And now, yeah, now I can tell it says 5 minutes total time. So, and it's starting with the face mill. I can zoom this in and out. All right, so I'm going to play it, roughing, rough and outside, step, there we go. If you go to verify and hit color loop, it'll actually subdivide everything by color. If I press this one, it'll be, oops, I did everything too fast. If I press this one, that's op 1, op 2, op 3, op 4, 5, 6, which I believe is some chamfering, another chamfer, spot drill the holes, tap the holes. So you can tell on here which ones take the longest by color. The blue one takes the longest. So, all right. So at that point, we're ready to post-process. You can use the G1 here, or if you're in machine, there's a big G1 right here. Post-process, NC file correct. Hit OK. Let's save the file. It'll actually save it by file name, but it's going to come out with program number. So hit save. This post process is from a previous version of Mastercam. No, okay, I didn't update my post. Okay. Code expert comes up. Because we just did the recent update to 2019, so, I mean, from 2020. All right, now this is updated. And up here I have Titan 1N cam, machine, BF2, date, time, material, tool list, and code right here. This all looks pretty good. Also has the 4th axis movements in here, which we're not running 4th. So, and there's tool 2. Z1 inch and all the other moves. So everything's there, and I did no lines. So, and you can run this directly. So we should be able to make a part with that. Okay.